So in this chapter, we are going to discuss that how can we use the what if analysis? How can we test a spreadsheet model? What are some of the characteristics of a modeling software? Explaining the needs for computer models and evaluating the effectiveness of these spreadsheet models. So the topic that we discussed in our last classes is connected with this one, modeling. And modeling basically means that you are actually creating a chart, you are creating diagrams based on your data. Your data could be based on some facts or figures, such as some numbers, and you can implement the modeling areas onto those numbers. Like, for example, if you want to create a bar chart, a histogram, anything like this, so that you can project your data into a diagram so that it's quite understandable to you. So this is what it is to be understandable by modeling. So basically, as per the introduction of this chapter, what is a computer model? This is basically a representation of a real world process. Like, I can say that models can be created through your mathematical analysis of the real world process. Mathematical analysis means that, for example, if I have a class and in our class I have 30 students, and among 30 students, I'm actually calculating the marks and grades of all of the students. So, right after I have done preparing the sheets for all of them, now I want to project that mathematical analysis into a form so that it's quite understandable to me, so that I can understand that which student is securing the highest one. There are several features when I take help of mathematical models, like I can analyze the trends. Or to be more specific, I can analyze the academics of a single student, or I can highlight some of the points of that, like which one is performing better, or which student needs improvement in which subject. So it makes me pretty clear and pretty evident when I convert my situations into mathematical models. So a computer model is basically a representation of a real world process, and a model can be created through your mathematical analysis of the real world process. The next thing that is right here is to be known as simulation. Simulation is basically like the use of computerized models to predict how real life system might behave. Like, for example, when you are creating robots, or when you are creating any virtual environment where you want to test a certain condition, and in actual you cannot do that because of certain circumstances. So you can do that with the help of simulation, because simulation is basically a computerized environment where you can predict that how the things would actually work, and then based on that simulation you can work on your real data. So basically this is all regarding the computer models, that first of all I create a model, a mathematical model, that can be of any real world problem, and just after that real world problem I create a model of that, I create simulation of that, so that I could know that how it could uh, behave. And depending on how it could behave, I can see the impacts, I can see the effects onto that, so that I can make a good conclusion onto that. So if I just conclude it right here, we have two learnings from this. That first of all, that what is a model? That is a representation of a process. A process could be anything. It could either be in your chemistry, it could either be in your physics. That means that you are creating a model, you are creating a simulation to test that how the things are actually working. And simulation is basically when you are using a model to predict real life behavior. The only difference between a model and a simulation is that a model is basically, a representation of a process, whereas a simulation is to be known as that you are basically like predicting the behaviors. So am I clear till here? Do you have any queries?
No, sir, it's clear.
Moving forward, we will be discussing these characteristics of the modeling softwares, and now we are going to discuss that how can we model them. So we do have different examples of modeling softwares, like spreadsheet is one of them, which we have already discussed, and it can be used to create computerized models. However, if you want to create a network model, a network model means that, for example, if you have two or three devices, or you want to connect them with each other, or you want to establish a connection, so you can use this clonix can be used to model a computer network. The softwares can produce a diagrammatical view of the devices connected to the computer network. It will be easily possible to identify the IP address, the DHCP. Other than this, when I talk about the animation part, like you might have seen that 3D animations, or if you are quite aware with the 3D animated films, you can see that these are basically objects that are like real life objects. Like, for example, if you ask me that how they are created, like 3D objects, so they mostly use softwares. Those softwares are named as CAD softwares. CAD softwares are basically known as computer aided design softwares, and they enable the designers to produce a model of a physical object. We have C computer aided design softwares, and they provides the user the functionality to produce models of a physical object that could include any physical object such as a kitchen, a building, a motor vehicle, or an aeroplane. These softwares can provide you with different functionalities. Like, for example, if you want to work in three dimensions, if you want to remove objects, if you want to model them from different angles, or if you want to apply effects. So all of these can be happened in this. Modeling softwares also include some essential features, like they there can be a question as well, like what can be some essential features of a modeling software. So you can write that these modeling softwares give you the ability to change variables within the software. You can ask what if questions, you can implement scenarios, you can implement different conditions, you can give formulas, you can give functions, you can give mathematical calculations, automatic recalculation of formulas and functions, rules that define how this model behaves. Like, these are the one which I am referring to. CAD software, you do not need to write the name of those softwares in your exam. You are not allowed to do so. They are such as your Autodesk, 3ds Max, like like this. You can create these 3D models. You can implement effects onto that. You can create your object, and taking it a step further, you can even use a 3D printer to print these objects. So these are basically those CAD softwares, and the features of that we have already discussed. Do you have any confusion still here?
No, sir.
Now we will be discussing that the need for computer models, and even before starting that, I want to ask you that why do you think that there is a need for these computer models, why there is a need for these simulations, why there is a need for me to study them, like why do you think do I need them? Do you have any guesses, any ideas?
Mm, I guess for the knowledge.
For the knowledge, okay, like for example, let me give you an example. Uh, do you know about cave mining? And you must be knowing that cave mining is definitely a dangerous process for humans, and many labor humans around the world even losses their lives in it. Right? Do you know about
Yeah.
this?
Yes.
So, what do you say that even before the mining starts, what if I first create a robot or something? Or if I can create a simulation onto that before actually starting the mining to see that if it is safe for the laborers or not. Are you getting the
Mm,
point? Like,
no.
for example, if I am going to simulate the conditions inside a cave so that I could better know that even if it is safe or not. And just knowing by the help of simulation that if I know that the conditions are not safe, I would not send the labor. Comparatively, without the help of simulation, just sending down the labors and costing their life. Are you getting the point?
Yeah.
Like with the help of a simulation, I can place all the dots at the correct place. For example, I can place the oxygen level into my system. I can place the other triggers into my system, and I can simulate that. That what if this happens? What if this happens? Is it going to be safe? Right? Like you can understand the impact of them. You can understand the conditions onto them. So this is one of the example. Can you give me any other example? Like even before creating vehicles, cars, right? They first go through their factory manufacturing, and even before coming into the market, they are passed through certain tests. Like they have done certain simulations onto that, that in conditions of these certain accidents, will the passengers be safe or not? So do you think that these 3D models are helping us out?
Yes.
Yes, because you would know the conditions, you would know the impacts. For example, if I create a simulation of a 3D car that just struck into a mountain and it showed me the fatal accidental death of all of them, this means that this is quite risky. Now, what manufacturers do? They again change the material of their car to something so that their passengers can be safe. Like just by implementing that in real life, they perform the simulation. Simulation means that it is all system based. So it helps us out. Are you understanding the difference?
Yes, sir.
Any queries?
No.
Now let's discuss from the book as well that there can be a variety of reasons that why these 3D models could be used, including your training, including your forecasting, including your constructions. Like whatever the reason is, a model must be able to answer what if question. And how is that? Because you can add your conditions into that. Models can be used for the purpose of training people to use their equipment. This could range from learning to drive a truck to flying an aeroplane, or just like uh, giving humans the uh, real simulation of real environment with saving costs with less risk of injury. Like I can use these models for training because there is a less risk of injury than in real environment. I can simulate them. When learning to drive a truck, the trainee may make a mistake by lifting a load too high that could cause serious injury and also cost you huge amount of money. But if I have that in my virtual environment, so this can help me save life. This can help me save cost, and at the same time, this can also help me save fuel as well. It is also possible to test certain conditions as well in unpredictable situations as well, such as turbulence, such as earthquake, that would happen in real life. Like models can also be used in your forecasting as well. So let's discuss this as well. We can also use them for weather forecasting as well. And one of the most common model for the purpose is a weather forecasting. Like in weather forecasting, we can identify the patterns that have happened in the past. We can predict that what the future might be. Is it going to be dangerous, or is it going to be safer? Business environments and government financials can be used to models to predict like what would happen in what might happen into profit, or the economy would be in loss. You can also implement what if questions as well. Constructions of buildings, kitchen, gardens, motors, vehicles, and objects are one of the very costly process. It is also possible to get first time. I will be also be giving you some assignments of questions as well. Like the first question is going to be, what is the difference between a model simulation? Models can also be used in your queue management as well. And queue management includes a queue at a supermarket, telephone helpline queues, and an amusement park. Like they can predict the number of customers and they can predict the number of customers, having rules that defines how long it would take to serve each customer, and it can help identify that how much staff would be needed to take care of them. Queues can be managed as well, whereas models can also be used to maintain your traffic flow as well. Like this can help in your construction side. In your construction side, it would come in helps in planning new roads, improving your infrastructure. You're creating your shopping malls, your residential areas. Like you can create your models that take into account existing traffic movement and project changes into that, so that you can experiment that how much traffic can go through one area to another area, what the impacts of it could be. So this is it. I have given you certain questions of this as well that I will send in the class with the class ends. Fine. Mm. Now the third area is what if analysis. What if analysis is simple. What if simply like you are questioning to a scenario. You are questioning it to someone like what if the situation is like what would happen. Like for example, I just asked like what if you do not study, or like what would happen if you do not study. So that is basically experimenting with changes variables to see that what would happen to those outputs if those variables are changed. You need to understand that wherever there is a situation, so there are variables that are responsible for managing and controlling that variation. So what if analysis is basically the process of asking the question. Like some examples could be like what happens to the total income for the month if we increase the selling the price by 20%. Like what would happen to our cost if we use a different supplier for one of our parts, or what would happen. So all of these questions comes under this area. What if analysis, the basic purpose of what if analysis is to set the goals, is to achieve like what you want to, so that you can play with those areas. Basically whenever there is a situation, there are variables containing that. So in the what if situation, you basically play with those variables around to understand that what would happen if these variables are changed. So for example, if I am taking your classes for twice a week, and just in case you leave everything and you do not study, that means that one of the variable that was into your journey was taking classes for me. But just in case if you leave it, now what is going to happen? Then definitely if you are not going to study, you are not going to get a good grade. So this is what an example of a what if analysis. A what if analysis you can put into anything. Goal seeking means that seeking what a variable needs to change for a goal in terms of an output to be achieved. So this is it for the first three areas, and I have jotted down some questions as well. You can complete them in any MS Word file and you can submit to me, so that I can see that how much you are able to write them. I have sent the questions to you on WhatsApp. Now we will be discussing 9.4. So in 9.4, we are going to learn that how we can test a spreadsheet model. So in chapter number 8, we learn how to choose the test data, and test the formulas, functions, and validation rules. Like when testing the spreadsheet, we discussed regarding these formulas, functions, validation rule, conditional formatting. Now, a test plan needs to be created to test all these aspects of the spreadsheet model. It needs to be clearly included, identify input values and the expected outcomes. Like the first area has area calculation, the data type is valid. So this is what we have done earlier as well into our spreadsheet class, and they are just creating some test results so that you actually get certain input values and expected outcome. 9.5 is basically how can you evaluate the effectiveness of a spreadsheet model. This can be another question. See, I just do not want you to copy paste the whole of the book right into your answers. I just want you to go through my lecture. I want you to go through the book and then write onto your own. I want to test that how much you can gain marks. Identify. Uh, Now, there can be definitely a variety of tools that you can use in order to test the effectiveness of a spreadsheet model. First of all, are the variables that can be changed to ask what if the questions. And variables are going to be your Excel sheet cell values that you can change to check that if in a certain condition, if it is working accurately or not. The second area is your formula then function, which defines the role of a model. Graphs and charts can also show a graphical representation of the forecast as well, or instant automatic calculations or conditional formatting to highlight the effects as well. Other advantages could be you can easily share the spreadsheet as much as people as you want. And spreadsheet do have their limitations too, but they are only as accurate as the formulas and the functions. Then I have is 9.6, and then the chapter is going to be finished as well. Now, 9.6 is basically advantages and disadvantages of using a model to create and run simulation. Now, at this point, you should be definitely clear that what is a model, what is a simulation. I create a simulation that is basically the use of a computerized model to predict how real life system might behave, and the advantages of that can be expensive prototypes or the real things do not need to be created. You can create them virtually. You can test them. You can change your variables. You can have your what if questions. The second advantage could be that changes to the model can be made very quickly as they do not have to be in real. Alternative models and designs can be used to see that how they act differently. Unusual events can also be tested, as I discussed with you, car accidents. Disadvantages can be that the way a simulation react is only as good as the model it is based upon. Simulation softwares can be very expensive. These are now the disadvantages. People needs to be trained as well. This can be another question from this chapter as well. That write down the three advantages of simulations. we can use the simulation in our natural disaster planning. Like I discussed with you with the example of coal mining. Like when planning for natural disasters, it could be really difficult to see that how things would prefer. Like simulations can be based on natural disasters such as earthquake, hurricanes, volcanic eruptions, tsunamis. Like we can experiment with them. What could be the possible changes? What could be the wind directions as well? Like I can definitely ask the what if questions. Pilot training is done as well. Like I just cannot give a beginner a pilot and ask him to fly. So other than that, we go on to the simulation part so that the cost is saved, the life is saved, the energy is saved. So the fuel is saved. So I just cannot give it because it would be quite risky. So flight simulation in your pilot training, we can use the simulations as well. In car driving, we use the simulations as well. This is the same for it. So this is it for this chapter. We are done. I have provided you some questions. You can complete them in your MS Word or send them to me or any way as you like. So in our next class, we will be starting the new chapter.